and welcome back to Computational Genomics Lab. I'm Kit, and today we will be talking about how to get the data that you got from running your pipeline. So first and foremost, congratulations, you ran a pipeline and now you have a lot of data to look at. So to access that, remember how when we were starting the S batch and running the pipeline, I was like, make sure you put an output folder and that output folder exists so your data has somewhere to go. So I will be showing you how to access that again. So the first thing that I'm going to do is I'm going to open my CyberDeck because it's cute and because that's how I'm going to get my data. I'm going to connect to Fiji because that is where I sent my output to. I did it on the supercomputer, so fiji.colorado.edu. And an important thing is make sure you're doing SFTP, so SSH file transfer protocol. Not changing that will cause a lot of heartbreak and confusion. So I'm going to put in my username, and my password's already saved, and I'm going to go ahead and connect. It has taken me to the supercomputer, and I'm going to go to the folder. So my folder is in Scratch and in shares, and I'm going to go to RN and my folder, and I put mine in this RNAseq pipeline, and my output folder is this Nextflow results. So I'm going to click into here, and I want to talk a little bit about some of these results that you'll get. I won't go over all of them. Feel free to look into them yourself, but the big ones are the pipeline info, salmon, and multi-QC. So first is the pipeline info. I'm just going to open up this first, this first one here and put it on my desktop so we can look at it. So I'll actually go into my downloads because it's being a little finicky with me, but it is in my downloads, and here's this execution report. So there's a lot of information here, but a big thing is it tells you how much like CPU usage, how much memory you're using, and not something that we really need to know for this class, but if you do go further in genomics and you want to know how to optimize your wall clock and optimize your pipeline in terms of time and power being used, you could use this report to change some of those parameters. So that's the pipeline overview. There's other files in there, but the most interesting one is indeed this execution report. So the next thing that I want to talk about is salmon. So salmon is super cool. If you remember, one of the files that we put in was a genome reference. And what's cool about salmon is it can also, you can put it in a file. And genes are interesting because the same gene can have different isoforms. So like it just looks a little different, but it is the same gene. And salmon, you can put in a gene annotation file, and it can actually look at what form of that gene is being expressed. So this could have potential impacts for when we're looking at the time course data to see if like a different version of that gene came on. Something else that I want to point out about salmon is, in a second, we're going to look at some analysis, some visualizations that Nextflow put out for us, and you'll see something interesting happening around the 48-hour, 96-hour mark. And we have these TPMs, and then we have counts. So the counts is just like the raw counts of how many like sequences were in there, and then the TPM is a normalized index. So like, for example, what if at the 24-hour mark the sequencer just like broke and it didn't like sequence as much in terms of volume of the RNA? So that's what this TPM does. It normalizes it so that if there is a different amount of depth in terms of sequences, that won't impact your analysis too terribly much. And now we are going to go to my favorite file so far. We'll go into the multi-QC folder, star salmon, and you want to look at this multi-QC HTML report. I already downloaded it, and I'm just going to pop it open here. And you can see that we have like all of this really cool data that's just already there for us, and that takes some of the legwork so we can drill even further down and do even more analysis. So don't be like, oh no, it already did the analysis for us. There is always more to analyze. There's always more to know. That is what is so awesome about science. But the two graphs that I really want to go over that will be good for y'all to know is this heat map and this PCA. I'm going to start with the PCA. If you remember, we had 3 replicants that we're looking at, and the PCA just looks at how similar things are to each other. So you can see that we have these like 3 clusters happening here. And the hope is that it'll be 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3 at different time points. So let's just look here. Yep, we have 0, 3, 0, 1, and 0, 2. So those are clustered. And let's just pick a random one over here. 48.1, 48.2, and 48.3. So we know that our replicants were similar to each other. So right off the bat, it's like, okay, good. We shouldn't see any weird outliers. And then this is what I think is so amazing. We're looking at that PCA, and now we're looking at a heat map that shows how similar each of those points are to each other. So this big square here is time period 0, so the very start, and time period at the 12th hour. And we can see that things are happening. They're similar to each other. And then when we come down to 24 hours, not quite as similar. And at this 48 and 96 hour mark, something interesting is happening. So we're going to do some more analysis on that, but that is how you can access your results from Nextflow and kind of see some first glances at exploratory data analysis. So I'm looking forward to seeing you in the next video, and let's keep doing some genomics.